We are done with workbench description. Now let us move on to customizing. So customizing a tree and geometry view. First click on tools, click on options. You'll get the option dialog box. Click on infrastructure and choose part infrastructure. You'll have general, display and part document. Here we have the tab appears containing 3 categories of options under display, that is display in specification tree, display in geometry area and checking operation when renaming. So under display in specification tree, there are 6 options available for customizing the specification tree display. First is the external reference. Then we have constraints, the parameters created using the knowledge advisor capability. If we wish to know what parameters, relations, bodies under operations and sketches. Display in geometry area, we have 4 options available for the customization of geometry display. Only the current operated solid. Then we have only current body option to display the geometry of the current body or open body only. By default, this option is no checked. Then access system display options let us define the size of access systems in mm. The parameters of features and constraints options permanently displays parameters attached to the part design features and sketcher constraints. Finally, the checking operation when renaming. 3 options let us define rules for renaming geometric elements using the properties command. Use the no name check option if we wish to allow all types of rename operations whatever the location of the elements in the specification tree. Use the under the same tree node option to prevent 2 elements belonging to a common node from having a same name. And if you are given an identical name, a warning message is issued informing that the element you are renaming will be suffixed as renamed. And finally, in the main object option to prevent 2 elements belonging to the same node from having the same name. Then we have customizing the general settings. Under this, we have external references, update, delete operation and replace. So external references, checking the keep link with selected object option lets us maintain the links between external references, copied elements, for example, and their origin when we are editing these elements. This option is used as we are editing parts, including in assemblies. Next, check create external references in show mode to define the visualization mode for external references or imported elements only. Then check confirm when creating a link with selected object. Check use root context in assembly to ensure that the root of the assembly is the context used. Uncheck this option if we prefer to use a minimal context. Check only use published elements for external selection if we want to make only published elements valid for selection. Check publish a face, edge, vertex or extremity if we wish to be able to directly select faces, edges, vertices, axes, extremities when using the publication command. Then comes the update. So check manual if we wish to control our update operations. Conversely, check automatic if we want part to be updated automatically. Now check the stop update on first error to stop the update process as soon as the application finds an error when building the geometry. Check synchronize all external references for update to make sure that the application updates elements copied from other parts. Synchronizing assumes that all modification to other parts affect external references, including in our parts. If this option is deactivated, the application will update only part. Check activate local visualization to visualize features as they are being rebuilt during the update process. Next comes the delete operation. Check display the delete dialog box if we wish to access filters for deletion. Check the delete exclusive parent if we wish to delete the parent of the features we are deleting. The parents will be deleted only if they are exclusive, which means if they are shared by features, they will not be deleted. When this setting is active, the option is checked in the delete dialog box, but by default, the option is not checked. Even if the option is checked in the delete dialog box, you can uncheck it if we wish to. If the display delete box setting is not checked, this setting has no effect. Next, we have customizing constraint appearances. Now moving on to customizing constraint appearances, we click on General, select Parameters, and select the constraints and dimensions. Here we have constraint style, dimension style, and display at creation. The constraint style is to set colors where appropriate by clicking on the arrow of the constraint type combo. A list appears containing different colors and colors available by default. We can choose any of these colors. And by clicking on Status Color Visualization, option displays only the colors defined for different constraint status. This means that if the personal color has been defined for a given constraint, that color is not visualized any longer. To choose between the constraints we wish to see or not in the geometry area, we have to click on the filter button. The constraint filter dialog box contains filter options available for all the constraints that can be defined for a geometry. The show all shows all the constraints and hide all hides all the constraints. Conditional filter, once activated, makes the options for the status filter frame available. We can then decide whether we wish to display constraint status or not, or display unverified or verified constraints. It also makes filter by type options available. We can also decide the constraint types we wish to display by checking the appropriate options. The filter by type, the last option, filter by type option, lets us filter out driving or driven constraints. The product frame contains the show on active product options. If activated, this option displays the constraints defined on the active product. This option is specific to assembly design workbench. Uncheck the constraints you do not wish to display and click on the OK option, this one. Then we have dimension style. Set the scale option to large. This defines the size of the symbol for tangency parallelism constraints. Small, medium and large are three options available under scale. Check the display iconified constraint element. This option increases the number of graphic symbols that we wish to see in the geometry area. The highlight pointed element to option to make sure that the application highlights the constraint elements when their constraints are pointed to. Enter the value to define the gap between the construction lines and geometric elements. For example, we can enter 2 mm or 4 mm. Enter the value to define the overrun between construction lines and geometry elements. For example, you can enter 2 mm, 9 mm, 10 mm as per our wish. Then we have display mode. Here, display mode option lets us to choose between the 4 options, that is value, name, name plus value, name plus value plus formula. The value, only the constraint value is displayed. Name, only the constraint name is displayed. Name plus value, the constraint name and value both are displayed. Name plus value plus formula, the constraint name, value are displayed as well as the possible formula defined for this constraint. Wherever we choose, it displays to all constraints that we are creating. However, we can edit each constraint individually by using the contextual commands available. And now for customizing a CAD part document, click on Tool, select Options and click on Infrastructure and then Part Infrastructure and click on Parts Document. A tab appears here, New Part by Create an Access System when creating a new part. If we wish to create a 3-axis system, which origin point is defined by the intersection of the 3 default planes, that is plane XY, plane YZ and plane ZX. When the CAD part is opened, the access system is displayed both in the geometry and specification tree. Now we have tolerancing. Again, we choose click on Infrastructure and click on 3D annotations and click on tolerancing. The default standard at creation defines the default standard at creation. Options like ASME, that is American Society for Mechanical Engineers, ANSI, American National Standard Institute, ISO, that is International Organization for Standardization, and JIS, that is Japanese Industrial Standardization, also provides 3 CAT-CADM standards for American National Standard Institution and International Organization for Standardization. Then we have leader associativity to the geometry, that is free option is for specifies the leader annotations for free positioned relative to their geometry elements, and perpendicular option specifies that leader annotations are positioned perpendicular to the geometric element. Again, we have to go and click on display. We have grid. Under grid, we have display, which defines whether the grid is displayed. Snap to point defines whether the annotations are snapped to the grid point. Allow distortions defines whether the grid spacing and graduations are the same horizontally and vertically. H primary spacing defines the grid's horizontal spacing. H graduations define the grid's horizontal graduations. V primary spacing defines the grid's vertical spacing. V graduation defines the grid's vertical graduations. And annotations in specification tree, we have under geometric feature nodes, which defines that 3D annotations should be displayed under the geometric feature nodes in the specification tree. This lets us to view the 3D annotations under the part design or GSD feature node to which they are applied. Next, we have under view annotation plane nodes defines the 3D annotations should be displayed under the view annotation plane nodes in the specification tree. This lets us view 3D annotations under the view node to which they are linked. Finally, under annotation set node defines the 3D annotations should be displayed under the annotation set node in the specification tree. Next, we have manipulators. First being the reference size, which defines the annotation manipulator size, and zoomable defines whether the annotation manipulator is zoomable or not. And then we have view or annotation plane, which creates views associative to geometry, so that the views and their annotations are automatically updated when the geometry is modified. Then we have current view axis only, which defines whether the annotation plane axis is displayed. Zoomable defines whether the annotation plane axis is zoomable. Visualization of the profile in the current view defines whether the view annotation plane profile on a part is displayed or not. By this, we come to the end of customization.